Finally, hello Internet. Welcome to yet another programming slash interview stream with yours truly, Abner Coimbre. Um, I am I am very excited and at the same time a little sad because this is going to be the last episode of the Handmade Dev Show. After this, spring break is next week, and I'm going to be taking 2 weeks off before I start, quote unquote, season two, expanding on programmers outside of the game industry. However, I am very, very excited and honored, I would say, to be able to talk to the guest that I'm going to be talking to today. And I would love to say, surprise, it's Jonathan Blow, but you already saw the intro scene here on Twitch showing the guest. So, no point in hyping there. So, um, my moderator is saying, hand mail. Sure, sure. I am working on some projects behind the scenes. That's for sure. And speaking of projects behind the scenes, handmadedev.org is hopefully going to be out by the end of this month. And this is very exciting because the reason for this stream, the reason for this show is to gather together programmers and the community to discuss perspectives on programming and thoughts on programming in the way that we consider to be handmade. And we can go into discussions about what we mean by handmade, but that's not the point right now. The point today is to have our guest. And our guest is going to be, like I said, Jonathan Blow. Hello, John.
Hello, hello, hello.
All right, we can hear you. Thanks
Good.
for coming to the Handmade Dev Show.
Yes, hi. Thanks for having me on.
For sure. Jonathan, I'm interested in knowing how you came about programming computers, and why did you decide to continue programming after all these years, right? So I kind of am asking you for a timeline about how you started programming.
Well, I didn't really know much about computers till I was about 10 years old, because this was a long time ago, all right? I was born in 1971, and computers were not a common everyday thing the way that they are today. They were just starting to become household things, in middle-class families or something, right? Mm-hmm. So it was like in the 6th grade, I was 10 years old or something, going on 11, and I was just got in some class. I guess it was taught to all the students, or maybe I opted into it or something, but it was a programming class, and there was a whole room full of Commodore VIC-20 computers, which I don't know how many people out there even know what that is, but it's not a very powerful computer. Yeah. It had, I believe, 4K of RAM. So that's some good stuff right there. Yeah. And it ran a basic interpreter or whatever, and the class was very simple, but I really loved it, right? And so my parents got me a computer at home, which was a pretty expensive thing for them to buy, but they saw I was so into it, and so then I would sit there at home and program all the time. Through most of high school, I would do various stuff. I programmed in BASIC at first, and then assembly language on 6809 and then 6502 processors. And then I eventually went to college, in college I sort of left that whole personal computer realm for a little bit and was doing Unix workstation kind of things, which is a whole different kind of programming, really. And sort of left low-level stuff behind for a little bit, because the first thing they taught you at my school, which is a well-regarded computer science school, University of California at Berkeley, the first thing they taught you was Scheme, which is a Lisp variant. They were doing sort of the same introduction to computer science that MIT does. So I don't think that's true anymore, but they did back then. So I did that, and then I learned C kind of in my spare time. And
in college?
In college, yeah.
Okay.
And then, you programmed in C in college as well, but sort of in different classes than the ones I was taking.
Gotcha.
So, and then it was only after college that I started really doing anything related to games and using C++ and things like that.
Okay.
I don't know.
Yeah. So did you enjoy the practice of programming, or were you just doing it to achieve like an end result because you liked the result of a work that you do by programming, not necessarily enjoying the act of programming? Or am I wrong?
No, I really enjoyed it, just
Okay.
sitting there doing stuff, right? That's what I really loved about it, to start with. In fact, my first program, I was in there in this classroom full of Commodore VIC-20s, and my first game that I ever made was the stupidest thing you could imagine, right? It was like, it showed a number on the screen counting from 1 to 100 really fast, and you had to try and
Nice.
stop it on the right number. And then, if you got it right, it would like do all these colors on the screen and stuff or whatever. And so I didn't have a very sophisticated idea about what to do at that time, but I wanted to keep doing it. So I kept putting in more and more like congratulations kinds of things that would happen at the end. So it was really silly, actually. So, and actually, I would characterize most of the stuff that I did all through until I went to college as being kind of aimless that way. Like, I was just doing a bunch of little things that were cool, and then I would go on and do the next little thing that was cool. I never really was working for a while to make one specific thing back then.
Okay, well, definitely. Then you were just like in a space of exploration during those years. So
Yeah, and you're really learning so much too, right? Like the first thing is just I'm programming in BASIC or something, and it's like, whoa, this is how computers work at all. That's like a lot to learn, right? Just like the way that you can make them do things with precise instructions and stuff. And then, back in those days, especially on home computers, BASIC and assembly language were the two options, and they're pretty different, right? So then you teach yourself assembly language, like from a book or something, right? And that's a very different learning process because mistakes are a whole different level of serious, and and the way you make programs happen is just at a different level of abstraction, right? And so there was just a lot of things to learn that way. And then, later on I was doing like simple demo type stuff on the Commodore 64 or whatever. And so then you're kind of starting to learn how the system works in terms of, how do the graphics get to the screen, and how do you tweak with registers to make it do things that you didn't expect it to, or that it wasn't intended to do. And I never got too much into that. I wasn't like in any kind of demo scene like Fabian was. And in fact, I would sort of say that I was a little bit unlucky in where I grew up and the social context around it, because I sort of ended up being the most interested in programming person of all my friends, like by a significant margin. So there was like not really anybody to learn from or to pick up ideas from. And, if you wanted to know something like how do I do a cool thing on the Commodore 64 or whatever, there wasn't an internet, right? So you can't just find out. You have to maybe find a book somewhere if you know what book that is, but then most bookstores aren't going to have it, and most libraries aren't going to have it. And maybe you would go on a BBS and find someone who knows, but it was really, if you weren't hooked in socially back then, it was actually pretty hard to figure out how to advance in skill. I basically went sort of up to the limit, with the first computer my family got. It was sold by Radio Shack. It was a TRS-80 color computer. I think it was called the Dragon in the UK or whatever, but it was the same machine. And at Radio Shack, they sold books that would come with it. They were like these big, like really wide and kind of thick books that had exercises in them, and it would say on it, like over 4 months of exercises inside this book, right? And they would get me one, and I would do it in like a week. And then they would get me the second one, and I would do that one in like 2 weeks. And that was it. That was all the reference material that you could learn from. Okay. So it was a very different time than today.
John, when was the first time you considered the idea of like starting a project that you think would be useful for people to use?
Probably in college sometime. I mean, I was still goofing around a lot, but I had various ideas. especially because I was going to college right when the web was starting. So I was like, oh, maybe I make a program that scans your website for broken links all the time and like lets you know if any are broken or something. But then I wouldn't ever do that. um, so yeah, I don't know. Like I said, prior to that, it was just messing around. And then, after college, I sort of either was working actual jobs for a couple of years, or then I started a game company. And then once you start a game company, you've got to be serious, or nothing ever happens.
So did you have like a lot of ideas or programming projects that were just on the back burner ever since you started doing like contract jobs and started your game company? And do you still have that list?
I mean, especially, I in college and a little bit after college, I was really interested in programming languages, and I would make little interpreters and compilers. So I probably made about 12 different programming languages at different levels of sophistication and different levels of completion of the project, And at one point, I did a lot in like the text mud community back in those days in the early 90s. And at one point I had a little programming language made for that domain. It was a little bit of a functional programming language. Like it had first class functions and, like hot code, interpretation and whatever. It didn't ever compile all the way down to machine language or bytecode, but it was sort of a syntax tree interpreter kind of thing, right? And I did that. That was sort of the furthest that I carried any of these. I had a fuzzy logic domain specific programming language, which was kind of interesting, but also kind of, in retrospect, not that interesting. So I would do a lot of things like that.
Okay. Now, I'm interested too because I don't know how much of your time, I would say your free time, you've actually spent programming aside from your actual jobs, because you are regarded as a person whose opinions are founded on a good vast amount of knowledge, right? So I'm interested in how you've obtained some of the programming knowledge that you've had and how you've applied it to game design. Like, how much did you do as efforts to study or to work outside of your jobs, or did you just gather all that knowledge while you were just working?
As a little pause before I answer that question, am I coming through really statically and clippy right now, or is it okay?
You sound perfect to me. Let's see what the chat says.
Okay.
Go ahead
if it sounds good to you, then that's fine, because you're coming through all clippy, and I'm not sure.
Oh, that's a Hangouts. Yeah, software's shitty.
Okay.
One way to solve it would be for me to leave the call and come back again.
I don't think that's necessary, because I can understand what you're saying. It's just,
all right,
for the purposes of the stream.
Yeah, we'll fix it during the break.
Sure. Yeah. So here's the thing about my personal style for my whole, let's say, academia and later, right, is that I always was more interested in my own projects than what school wanted me to do, right? So even all the way back in high school or whatever, I would go home and I wouldn't really do my homework. I would like program on the computer, right? Because I only ever had 2 computer classes in like 8 years of relevant school. So most of that wasn't what anyone was telling me to do, right? It was mostly self-motivated things, right? I would go to college and, there would be a bunch of computer science classes with various assignments, and I would sort of go to the classes and learn the things, but I was way more excited about doing whatever personal project I was doing at the time. So I would spend most of my time working on that, and some of those classes I got pretty bad grades in. Like I think it was really ridiculous. Like, because I also like a lot of the undergraduate classes were relatively boring. So I was taking graduate classes a lot of the time, even though I was an undergraduate student. But then sometimes I would just stop going to the class, which is really unusual for like a graduate class. I don't know. They were like, what the hell is this guy doing? So that's really where I learned the best. Like I learned the best when there's something that I'm really motivated to understand. And I was most motivated to understand whatever interested me at the time, which was usually not what people were trying to teach me. Although the things that people were trying to teach in school were fine. And, I picked up enough of that and then it was sort of reinforced by the things that I would go do on my own initiative. So that's really where I learned most things. Even when it comes to professional life or something, you're building a large video game, and sort of the form that takes kind of depends on what interests you, right? You're going to build an engine, and you're like, well, what should the engine be like? I've always been interested in far view distances. I started making my first game engine in 1996 when, to the extent that there were 3D games, most of them, if they were outdoor engines, there was like a terrain renderer and then like a wall of fog 10 feet in front of your face, right?
Yeah.
If you ever played like Magic Carpet or Terminal Velocity or any of those games, you know what I'm talking about. So I was interested even back then, like, okay, how do we make an engine where you have a very far view distance, right? And indefinitely far view. That was an interesting technical problem to me for whatever reason, right? That was more interesting to me than other things. And that sort of drove what personal research I did and what things I tried to understand.
Okay. Now, were you ever unhappy with some of the tools that you've had to use to build these games?
Are you kidding? Yeah, tools have always been terrible.
In what ways?
So here's the thing: let's take when I first was making professional games, starting in 1996 as a pretty good reference point. Okay. That's 20 years ago. That's a nice round number.
Sure.
Some things were better. Like Visual C++ back then was way better than today. Not in the sense of, supporting as many language features or anything, right? Obviously, both C and C++ have more features and are more robust languages and stuff. But it compiled your code way faster. And, the interface, the program sort of felt like it was made for a programmer. Like there was this IDE and it sort of helped you do what you wanted to do. And there was some stuff in there that I didn't care about. Like there was this weird icon editor or whatever if you click on the wrong thing. And there was all this stupid like auto generation of AFX files or whatever all that Windows stuff was. But there was little enough of that you could kind of ignore it. And then you had a program that was at least ostensibly helping you do what you wanted to do, right? Compared to Visual Studio now, which is this giant bloated program that mostly causes problems.
Yeah.
And that mostly, like almost every menu item and almost every option in the entire program is something I completely don't care about. And most of it is things I don't know about. And there are reasons for that. Like I think Fabian was saying the other day, well, look, it's not necessarily made for you. And that's fine, but then why are we using it, right? So
it's the only thing out there.
Yeah, but part of the theory, we can get to this later maybe, but part of the theory that I'm adopting for my new language is we're not really using that to do very much anyway. Like the only valuable part of it is the debugger. So to build a program, you actually want that to be as simple as possible. You don't want all that stuff because it just gets in the way and makes you less portable. So anyway, so on the other hand, so that's a thing that's worse. A thing that's better now is, and it's about to get worse again, but for a while, Windows actually got better, right? So, like back then, we would be making 3D engines and I'd be having to do texture mapping pixel by pixel, and we would do this cool stuff like, hey, let's take over the stack pointer because there's hardly any registers on the x86. So, Mike Abrash and Chris Hecker and people like that published articles about like, here's how you do fast texture mapping. Mike's was like the first and the most sort of thorough and amazing one, I think. Because he came up with, for Quake, he came up with this 6-cycle per pixel texture mapper, which was an insane thing at the time. And it used a couple of tricks and quirks of the x86. So we'd be doing stuff like that, like figuring out how to take those things and build an engine around them. But when you're down at assembly level like that, it's really easy to do something wrong and start hitting random memory somewhere, right?
Yeah.
And if you did that on Windows 98 or earlier, memory wasn't protected hardly, right? So you'd just kill your machine.
Yeah.
So you'd be rebooting all the time.
Good point.
It was not a rare thing to have to reboot. Whereas now, if you do the equivalent thing, you have good memory protection, and your process dies, and the debugger probably catches it, and you see what happened, right? That would happen back then if you were lucky, but it was certainly not guaranteed.
Yeah, but you say that that's got better, but what got worse, or what might get worse again? I'm not sure.
Well, Visual Studio got worse again, right?
Okay. Yeah.
Everything around how you build and deploy a program has gotten worse, right?
Oh yeah.
Just all the different. I haven't even been following what Microsoft officially wants you to do these days if you're going to deploy a Windows program, but there's like something with assemblies and whatever the hell. Just forget all of that stuff, right? It's I don't know.
John, how do you feel about this is a little bit of a long question, but bear with me.
Sure.
Yeah. Many of the proponents for tools or languages that we consider, at least in the community, to be bad, let's say Java, just to give one example. Proponents for that say, well, here's the thing. Programming can become really complex, obviously, as what you want to do grows in complexity. So you want to forget about all the details of what the program needs to do in reality to solve the problem, and just create a conceptual notion of your entities. A good example could be, let's say Java doesn't have any mechanisms for creating, let's say, time. So if you want to say that the time is 3 o'clock, then instead of doing, okay, two integer variables, one with time, one with minutes, seconds, milliseconds, right? And it keeps growing your list of variables. You can just define this class that wraps everything together into one conceptual unit, and then you can consider your program time as just that one unit, right? And they're like, this is a valuable thing, they're saying, for a language to define mechanisms to make these notions that are conceptual feasible in your program. So you can just think about them at a conceptual level. Do you find that to be a useful thing? Because at the surface level, it does sound interesting or tempting.
No, I have no problem with abstraction in general. I think you need a certain amount of abstraction, or you'll just go insane, right? Now, I don't particularly like Java, in part because it's built around certain ideas of how you are supposed to program that I don't agree with, right? But I'm not going to get too deep into those arguments, because you know what? I have hardly programmed in Java at all, because I look at it and I go like, I've got other things to program.
Yeah, I got you.
So I'm not even super familiar with the nuances of Java. But the thing is, there are multiple things that I have to say about this. So number one is, abstractions don't ever actually make things more simple, right? They make the program itself more complicated if you view the program as a whole, because without the abstractions, you have a bunch of low-level things, right? Then you add some abstractions on top, that's more code. And it's not just the amount of code, but it's the, if you're going to understand this program, there's then additional like constraints that you need to understand, like at which times is it okay to call this thing, versus that thing, and how do the return values of these things relate, and whatever, right? Can vary tremendously based on what the actual code base is. But that's the thing. So if you're responsible for understanding the program as a whole, abstraction never makes the program simpler. Now, what it does do is it allows you to temporarily forget about things, which is very useful, right? Like, okay, I don't have to remember what I did in this texture mapper. I'm just going to say draw triangle for a while, and I don't really need to think about it, unless suddenly I need to think about it, because sometimes, if you get serious enough, at some point you always need to think about going back through the abstraction barrier and seeing what's under there. Because there's going to be something, right?
Yeah.
Sometimes it's memory patterns. Sometimes it's time. Like, just how do I have a guarantee of how long this thing will execute in, right? Like, I'm sure NASA does a lot of hard real-time stuff, right?
Yes.
Which is a very serious kind of programming to do. And
Yeah, you can't have the garbage collector run at T-2 seconds, right?
no, I mean, it's hard real time is very hardcore. So that's one thing, is that it always makes the program more complicated. Now, if you imagine that someone isn't responsible for the whole program, then an abstraction can be nice, because you say, okay, I'm presenting to you sort of the intended way to use this thing, and I'm sweeping a lot of stuff under the rug that you probably don't have to think about. Okay, that's great. None of that requires objects or inheritance or anything like that, right? None of it even requires wrappers necessarily, right? So, because there's a difference between, I'm going to provide suggestions or intent of how you're supposed to call into this code, or nice entry points is one thing. But somehow there became this culture of, we're going to wrap this thing in layer after layer after layer. And if you don't have 10 layers of glue code, it's not right, which I think is ridiculous, because by the time you add that many abstractions, it's a mess, actually, right? You've made the program so much more complicated than it would have been without them. And that seems to be the Java culture, actually. There was this one thing that I retweeted on Twitter that went around. It was from this guy's blog where he was doing an HTTP request, through the standard, some Java framework, right? And the call stack was like 100 things deep, and that's not even an exaggeration. It just went on, right? Maybe we can dig that up and tweet it later. Maybe someone knows what I'm talking about and can do it in the chat. But so there's, everything can be taken too far. All right. Now, so the thing about abstraction is it takes away context, right? And the more abstract you get, the more problems you create in terms of somebody trying to understand your code. So, for example, a real world case of being too abstract. I used to do some contracts at game companies, and I did some stuff on the Unreal Engine in like the early to mid 2000s. And if you ever had to debug like loading code at that time, it was completely crazy, because it was so genericized that you couldn't tell like what you were loading, like what type it was, like where it was coming from. It was just genericity after genericity, and you couldn't. It was crazy, right? There was you couldn't even tell what the control flow was, because it was built in such a way. I don't know if that's how it is now, right? But there's some point at which things become so general that you can't tell what they're for or what they're doing. And that's bad. You've gone too far at that point, because we're human beings, right? Human beings understand the world through what they can feel and touch and see, right? And if you take away all material properties from an object, we just don't understand it anymore. So there's, at one end you have, okay, this is too many implementation details to think about all the time and I'm going to go insane. And at the other end you have, this is so abstract that it doesn't even stick in my head and I have no idea what anything is. And you actually want to be somewhere in the middle. And that's a fine point that I think is not particularly understood lately.
What about, so there might be a nuance between this talk of abstraction versus, let's say, libraries. Because when I was talking to Casey a few weeks ago, he was saying, libraries are a good thing. It's just that we have bad libraries right now, right? Because you have a build system for your build system that generates the code. Then you have to compile it. The entry points are difficult to understand. And for your data sets to actually fit into those API entry points is horrible, right? So do you believe, like he does, that maybe, let's say this Handmade community is trying to maybe rebuild better libraries that solve these kind of problems that we have now? Can they be actual building blocks for us to use and not have to worry about them again? Or do you still think that we have to be in that point where we have to understand what's going on behind the scenes?
So I think that there's a fine art to building a library. Right? And I actually talked to Casey about this a while ago, and it clarified my thoughts on it as well, right? So I think you absolutely do want to provide very abstract, or not, let's not even say abstract, like very non-detail oriented ways of doing things. And I say not abstract because maybe they're for doing very concrete things, right? So for example, I was involved in some of the first game jams. Chris Hecker and some friends started them like back in the early 2000s. And our friend Zach Simpson had this library called Z Sound, right? And it was the most brain dead thing that you could imagine. The API was like play sound and then the file name of the sound effect, right? And it would like load the sound and play it out. And if the sound was already loaded, it would just keep it, right? It wasn't loading it from disk every time, but then it would just like play it through wave out on Windows. It was very fire and forget. It was absolutely not a AAA game production quality way to play sounds. But if you wanted to write a program quickly and didn't need a certain level of robustness in the sound system, it was great. It was the best thing. Like I actually had some sound stuff that I'd done for my games, and I was like, oh, why don't we use that instead? But it didn't load as many formats as well, and it was picky about what sampling rates it wanted to mix and all that stuff. And all those things got in the way, right? Mm-hmm. So like Z Sound was great because all you had to do is say place sound and the name and not think about anything else, and it just handled it. So that is great, and that's ideal. And like I said, it's not abstract because you know what you're doing. You're playing a sound effect, right? And you know where that sound effect comes from. It's a file with a certain name on disk. So those are very tangible things that are easy for the user to think about, right? Mm-hmm. Now, I think, so that's step one, is can you do that? Can you find a thing that's very useful that people want to do and make it very easy to do? Most libraries fail there already. Like most libraries think that you want to understand a system of how to use the library, which nobody does. Nobody gives a crap about like what you think is a nice system for making people just forget all that, right? Just make it as easy as possible for me to do exactly what I want to do in as simple a way as possible. So now once that has happened, right, then inevitably, as we've been saying, you're going to have some layer on top that you call into, and then you're going to just have a ton of implementation details under there, right? So then the next good thing to do is factor those implementation details in such a way that they're usable on their own. If somebody is so inclined to dig down past that top level of detail, because maybe they need something more robust or that works in different situations than what you wanted to provide, but then
you're talking about granularity, right?
Yes, yes. So, an example from the conversation Casey and I had was, okay, so maybe you provide a very high level system. Maybe it's even like part of a game engine or something, and it works with the rest of the game engine to like automatically play proximity sounds for entities or whatever, right? Okay, that's very useful if you buy into that system, but if you don't want to buy into that system, can you reuse any of it, right? Okay, maybe there's some really nice loops that will mix, stereo or 5.1 or 7.1 or 8.1 sounds, very quickly into like a target buffer, right? That's a reusable component that's low level, but that can be very well isolated and made to not depend on any other assumptions. So you could then reuse that, right? So to the extent that the library author can identify those things and then provide them, that's very nice. And I don't feel like we have a tradition of that kind of hierarchical abstraction design. At least I've never seen it done well in hardly any cases.
Okay. And, let's bring the topic to, this is something people want to talk to you about, which is, and I'm not sure I want to dig too deep into that because I hate the topic, but it's object-oriented programming, right?
All right.
So just if you're inclined, just give us a few of your thoughts on that.
Well,
you don't have to.
I mean, I don't particularly buy into it, right? I do use inheritance in a very limited way, but even the way in which I use it has turned out to be bad in many cases, right? And I talked about that in some of my programming streams. So, for entities in a game, you would think like, oh, it's a very good thing to have like an entity-based class and then, the door entity type, right, which you instantiate for every door in the game, or the puzzle entity type or whatever, right? Mm-hmm. And in C++ at least, that turns out to be very bad for performance. And there's no way around it, essentially. You basically have to rewrite your entire program, which kind of sucks.
Yeah.
So actually one of the language design things I'm trying to do is make that level of relationship work without so many constraints on what the memory layout is, right? Because it's really a conceptual division that you're trying to do there.
Exactly.
right? And then C++ ties that to memory when it maybe shouldn't be.
Exactly.
However, that simple relationship is only one small part of what object-oriented is usually considered to be. Usually object-oriented is something about encapsulation and responsibility. Like this thing owns all of a certain kind of functionality, and you have to call into it the way that it wants in order to do those things. And it's all very clearly delineated and hierarchical and whatever. And real problems aren't that way, is the thing, right? Only toy examples in OO books are that way. So, my there's this thing, when people started to, in the programming language research community, started to invent other languages like aspect-oriented programming or whatever to go after what they saw as the drawbacks in object-oriented programming. There was this term invented called cross-cutting concerns, right? Which is just, okay, if you've got one piece of code that's supposed to have full responsibility for one concept over here, and you've got another one that has full responsibility for one concept over here, a lot of times there's maybe things that equally involve both, right?
Yeah.
And then you could maybe refactor your program to put the concepts different ways, but then there's going to be other things that equally involve. You can't ever get rid of those, right? They're always there. And sometimes there are a lot of them. And so the thing is, I actually don't like the term cross-cutting concerns because it makes it just seem like, oh, there's a couple of concerns, right? And everything else fits into objects. But that's not actually how it is. Like, probably half of what you need to do or more is really cross-cutting if you're not blinded by this OO methodology. And you just let it be the concept that it wants to be,
that's
right? So I'm a big believer in looking at what your program wants to do, or needs to be done, and just doing it that way, right? And for the domain I'm in, that usually includes performance aspects of the program, which apparently most programmers don't even think about anymore, or they think they're thinking about, but then what they produce is a disaster, right? So, but even if you ignore performance, there's just so many things that connect every part of your program to every other, right? And in games especially, because it's like this rich simulative kind of thing, right? There's no such thing as just simulating an object in a game. You also care about what that looks like. And so the code to simulate is doing a lot of things related to the renderer and, whatever. So, and input, and everything touches everything. And you do your best to factor it out into clean things. But it's just not ever completely factorable. And at some point you just accept that and you say, okay, this is the neatest organization that I have for this. And then I'm going to sort of have a bunch of stuff that lives in between, and I'm going to be relatively clean about how I set that up, right? Now, once you've done that compartmentalization into all these different ideas, I don't find that objects are usually the best way to do that. Usually it's just a file for me that does a bunch of stuff. So here's the file that does all the stuff about puzzles. Here's the file that does player input, right? That for me is enough of an organizing principle. And because again, objects, especially as in C++ or whatever, ties functionality to state, which is maybe not that good of an idea. Sometimes it's a good idea when you're naturally making a thing that you might instantiate a bunch of times or whatever. But in a game, you're actually paying a performance penalty for putting state in an object that's heap allocated, right? If it's like your player control state that there's only one of in the game, right? So it's just, there's too many things in OO languages are associated that shouldn't be. And I know that C++ is not nearly the only OO language, but a lot of other ones are worse. Like D, for example, which is trying to be a better C++, right? And is in many ways a better C++, has this bizarre thing about heap allocating some stuff by default.
Oh.
And you're like, what are you doing, man?
And you can also engage like the garbage collector if you're not careful. So if you use some language features of D, you're accidentally engaging the garbage collector, and you always have to have that in your mind. What I shouldn't
Yeah,
use from the language to not engage it. That's already a bad.
yeah.
Uh,
And that's not really OO anymore, but it's a different
it's
thing.
a
It's
different
like
thing.
there was some idea that the D people had about how you're supposed to program, and they made their language encourage that. And that idea is actually very different from what I think. So, D will tell you like, oh, the garbage collector is optional and stuff, but like, I legitimately challenge anyone to write a 300,000 line program
exactly.
that does not invoke the garbage collector, and let me know how that goes for you, right?
Yeah, and you can like disable the garbage collector from the very beginning, but that doesn't stop you from engaging in it, and then it will never collect, and then you're screwed at that point. So
Okay, and then you can't use any libraries ever, right? Because most of the libraries are going to use didn't ever decide not to use the garbage collector. So it just doesn't work that way. That's just not this is not how it goes.
Yeah, and
So
yeah,
I mean, none of these languages are OO anyway. Like C++ is not even object oriented compared to the original definition of object oriented, but that's a bit of a sidetrack, right?
Yeah, it's an interesting topic too. But I do find interesting how if your problem domain is inherently if it inherently requires performance characteristics, right, to be evaluated in a way it needs to be as performant as possible. Let's say again, space exploration or games. Then these sort of ideas sort of break down, like object-oriented programming. If you engage in that methodology to its full extent, then you won't be able to solve your problem. At least for the ones that require high performance characteristics.
Yeah, but the thing is, I agree with that. But that if is not a small if. Like I think that there's a big place that we're failing these days.
Okay.
And I just gave a talk about this a couple of days ago at UC Berkeley. And I'll just recap the basic idea because I went back to Berkeley to give a talk, which is where I went to school for computer science, right? 25 years ago, and I looked up how many flops the fastest computers in the world had at that time, which were connection machine CM5s, which were these giant refrigerators that you would network together, and they had hundreds of processors, right? My phone beats that now. My phone would be on the top 5 supercomputer list of 1993. And we started to have the World Wide Web right back then, right? You'd go to a web page and it would take about a half a second to load the page. And then you'd have a web page with some information on it and stuff, right?
Yeah.
Which is about how long it takes today, even if you run an ad blocker. Yet, most of the things serving those pages are, this is a frickin' supercomputer, right? This could have simulated nuclear explosions for Lawrence Livermore Labs in 1993, right?
For sure.
Your average server farm machine, or even my desktop machine right here, is incredibly faster than that phone, right? We have super computers serving these web pages and stuff, and they still take a long time, right? And then if you scroll down your page, it kind of janks and whatever, and then you have to reload it half the time. Like the web is actually a worse experience now than it was in the mid-90s when it was starting. And it's crazy, right? If I were to go back in time to then and imagine, the web is kind of interesting now at its inception, just imagine how cool it's going to be when the world is serving all these web pages from supercomputers to supercomputers. You're going to it's going to be so responsive and intimate. It's going to be, like the most amazing thing. Like if you imagine what a really good VR rig is like right now, like running at 120 hertz and you just like look around and all the objects move and it's like you're there. That's what the web should be because it's so much easier. Like we run this freaking 3D world that will convince you that you're there, right? But somebody can't render a flat web page that responsively, okay? That's just a massive failure. And if you start to, you start to defend that by like, there's all these layers of abstraction in, JavaScript or whatever, all of which is garbage that shouldn't exist, right? it's still not a reasonable defense because even native applications don't run that well.
Exactly.
You know,
Yeah.
like I did this other thing. You know, I had this thing in the middle of my talk where I wanted to pop open an image that was out of my slideshow to illustrate something. And really what I was illustrating was how damn long it takes Photoshop to start up and render an image on this thing that is a super computer compared to the 90s, right?
Mm-hmm.
And, you know, it took 15 or 20 seconds or something, right? On my
Wow.
Razer Blade 14-inch 2015 with an SSD, like a really fast SSD. But the funny thing is, the very first thing when you run Photoshop, the very first thing that happens is it pops up an image. And it's this very nice image that says like, it's pretty high res. It says Photoshop and has some names of people, and then it prints the loading DLLs and stuff on it. Mm-hmm. And then 15 seconds later, you get the actual image that you wanted. So it shows you how fast you could actually get an image on the screen, right? And I'm sure they didn't even try to make it that fast, but you run it, and it's like, bam, now I'm waiting. And then, oh, is it done? No, this other thing is, no, oh, and then finally it runs, right? So basically, the thing I have realized now is pretty much exactly 0% of all software that I use is fast enough. Like, it's all frustrating, it's all slow, it all doesn't work, right? We're on frickin' Google Hangouts right now, and you sound like something out of a Alien 7, where when you're on the ship and like the talking is all distorted because it's like we're losing reception and then the aliens are about to attack, right? Like, why does none of this stuff work, and why is none of it remotely fast, right? Computers are going to stop getting faster pretty soon, I think. I mean, the rate at which they're getting faster is slowing down. So if software keeps getting worse, it's just going to get crappier and crappier until it doesn't do anything anymore, which we're already about halfway there, I think. So
I'm getting depressed.
that if that you said about if something applies to all consumer software, certainly, and probably a lot of business software too, because in business software you care about how fast you get your results and whatever. So I really don't find that. I mean, people will say, "Oh, we don't need to care about performance in our domain." I think most of those people are wrong, actually.
Yeah. Wow. You know what you said is maybe a little sad because it makes me think of the future, right? Like what are the steps that programmers that actually do care about these performance characteristics, that actually do care about sending quality software to the users, where we care about their time? What can we do in order to maybe address some of these issues? And I think your programming language is a thing that's trying to address these issues. So why don't we go ahead and talk about that?
Well, that's one way, right? So I think in general, here's a thing that happened, right?
Okay.
So C happened, and it took over from some other languages that maybe were better in some ways, actually. So like Pascal is actually better than C in some ways, especially when it comes to, you know, not accidentally passing the wrong type things or whatever. In fact, the C that I learned in college was K&RC, which is way worse than C of today, right? In K&RC, you didn't even get type checking for function arguments ever, right? Because your function prototype was just parentheses with nothing in it. Right. So it was very easy to, and if you passed the wrong thing, your program would just crash, and the compiler probably wouldn't help you that much because your stack was probably wasted, right? Mm-hmm. So all sorts of stuff like that we think of as very, very basic safeguards now. In the late 80s, early 90s were not common, right? C89 started fixing that stuff, but that didn't really become too common until a couple of years later. So there is this, I just give that as an example of how much better a small thing can make the situation of programming in a particular language or a particular paradigm, right? Now, something that happened in the 90s and 2000s was, for example, people said, well, all this stuff about manually dealing with memory is horrible and it's a big cost. So obviously you should use garbage collected languages. You know, up till now, that's always been functional style languages like Lisp or whatever, but we're going to start doing garbage collected procedural languages like Java and stuff. And that's the new thing. And that's what it means to be high level, right? And high level means you don't think about memory, right? That's kind of an assumption.
Yeah.
It's a very big assumption. And, you know, I think it's very incorrect. And I think the price paid for that is much higher than most people understand. So one thing that we can do is go back, sort of rewind to there and say, okay, wait, I don't agree with that assumption, but it's true that that is in reaction to a problem, right? Garbage collection does actually solve some problems that people had. And it didn't just get made up out of nowhere. So what are some other solutions to the problem, right? So the LLVM community has done some other stuff lately, right? So they have stuff like address sanitizer, which is that's not only about memory allocations and stuff, but it's a way of making sure that you don't do bad stuff reading through pointers and things, right?
Yeah.
But there are techniques that can be applied to get rid of the vast majority of problems, because most of these problems are very easy to detect. I mean, let's take another really dumb one, right?
Okay.
So in C, a mistake that some people made commonly was they would say, if open paren x single equal sign 5, right? That's not one that I make that commonly, but it happened enough and it took people long enough to hunt it down that actually people decided, oh, the way you should program C is do this Yoda thing where you reverse the x and the 5, right? So you should say 5 is equal to x or whatever.
Yeah.
And that way, if you put a single equals, it'll tell you that 5 is not an L value, okay? It's like, okay, fine, maybe, and then maybe as your clauses get more involved with more and or operators, that gets harder to think about. But like, that is so trivial to generate a compiler warning about.
Yeah.
And yet nobody did it. I don't know when they started doing it, but it was a long time, right? It was a long ass time before compilers would say that. It was a long time before C compilers would try really hard to avoid burying you in an avalanche of errors every time. So there's progress there, but the progress is coming slowly. Now, I think if programmers got very clear about the fact that the compiler is your user interface to writing code, and that, like any user interface, you want it to be as nice as possible about communicating with you, that would cause a lot of things to get better immediately. Right. And so that's what I try to do when I work on my language. Now, it's not so easy when you're building a language to also make it as nice as possible, because you don't even know what it is yet. But I try to never let things get too bad. Mm-hmm. And I try to always think about, okay, what is the story here behind what we're going to do to help you find errors and stuff like that. So I think there's a tremendous amount of stuff that can be done, and it's all low-hanging fruit, and like nobody's really gotten serious about it as all. Okay. And it doesn't require committing yourself to some really heavy decisions, like now we're going to automatically collect memory and slow down your program and massively raise your memory requirements in order to run and stuff, right? Like that's a very serious decision. You don't have to do that for most of these problems. So I would just like it if people would explore some of the easy things that there are to be done. That's all.
All right. And, with that, I'm interested in talking more about some of the things your language has already accomplished, just for the people that haven't really seen your videos. But we'll do that after we take a 3 to 5 minute break.
Okay.
It's been an hour.
Let's make it on like the 4 to 5 minute side, because I got to boil some new tea. My tea here is cold. So.
Okay. Yeah, no problem.
All right.
Yeah.
Cool.
So I'll call you out when we come back. No problem.
Right on.
All right. Talk to you guys soon. Go to the bathroom. Have your beer, people. And I will see you back here with Jonathan Blow and me talking about JAI, which is his programming language. And we'll also be talking about the questions that you have for him. So get ready for the Q&A session, okay? Have your questions ready, because I'm going to have him answer them. Hello, Internet. Welcome to the second half of the Handmade Dev Show, season finale before taking a 2 week break. I am here with Jonathan Blow, where in the first half we've talked about really interesting programming subjects and how he became a programmer. And we left talking a little bit about what we can do to address some of the issues we've encountered in the software development community. And, we've been talking about his programming language efforts, JAI, or Jai. And I was listening, well, reading on the chat, John, and also from tweets and things like that. People saying that making a programming language to solve some of these issues is a little bit difficult to do. So, what do you have to say to people saying that making a programming language is a hard, difficult task that you won't be able to accomplish?
Well, I'm confused because I have made a programming language that runs and it's fine, right? So it is not a production quality releasable thing yet. But it's more production quality than like the first versions of JavaScript or PHP ever were already. And look at how popular those are. So I think very often people have status quo bias, right? Where they feel like because things are a certain way, it's very hard to make them not a certain way. But that's not true. The world changes all the time, right? In big ways and little ways. And you know, if you're around long enough, you just notice that's actually the regular thing, is that stuff changes a lot. So the question is just, is the programming language that people use for low to mid-level-ish stuff going to change from C++? And the answer to that is, of course it will, eventually, on some time scale, right? Like, what 500 years from now are people going to be programming in C++? No, I don't think so, right? That would be completely absurd, right? 100 years, no, I don't think so. Okay, 20 years is kind of a stretch to think that in 20 years C++ will be anything besides like what Fortran is today, right? Where maybe there's some people who for very particular reasons program in Fortran, and maybe there's some legacy code bases, but aside from that, whatever. So, and whether you believe that 20-year figure, whatever, right? There's some number for which that's true. So what language is it going to be that people switch to? Hopefully something that can fulfill the same needs as C++, right? It might be Rust, right? Rust has some things that it does that are interesting. If we end up taking safety as the biggest priority, right, then maybe Rust is the best language right now that we know of for that, right?
Yeah.
I think probably not D as much as I like D because, again, of the garbage collector thing. That's kind of a no sale for me. And most languages actually use garbage collectors, right, in one way or another. So like Nim or I don't know, any of this stuff, they all bought into that idea that you're supposed to garbage collect because that makes the programmer's life better. So if you think that it's important not to garbage collect in order to have the applicability to many people, there actually aren't that many languages even trying right now. There's very few. And so it's actually, if you're a credible contender in that field, it's much easier than if you're trying to make the new language that's like the high-level garbage collecty thing that you make phone apps for, right? There's lots of people trying to do that. So whatever. I mean, it's not, when my first 2 videos about the language were just idea videos. I hadn't sat down to like type anything yet. And all sorts of people said, oh my God, it's so hard to make a language, you'll never do it. And I'm like, what are you talking about? I've made like 12 languages, like I already said, right? And yeah, they weren't production quality things, but I also know exactly what it takes to ship complicated software, right? So you look at something like The Witness, right? That's a complicated thing. It's more complicated than many, many games. And we shipped it on 2 platforms at once. And while that was a very interesting experience, it gives you a very accurate idea of what you can do in a certain amount of code and a certain complexity of code. And I think that for this compiler to be production quality is much, much easier than to build The Witness, for example. I think The Witness is probably at least 4 or 5 times as much work
Oh boy.
to get an initial product. Yeah, no, think about it, right? So what's a thing that you might feel like you need in a compiler? Like, oh my God, you need to be able to debug your program with a reasonable GUI so you can see what's happening, right? Okay, cool. Yeah, that's a thing that you need to do probably to get people to use something. It's got to work pretty well. It should look nice and feel good if you want people to feel good about using your language. How hard is a frickin' debugger GUI compared to an open world 3D game with 60,000 entities in it with no maximum view distance, where you walk around and there's all these shaders and stuff, and like that's way harder.
Good point. Yeah.
Way harder than a debugger GUI. Like, what are you people even smoking, right? People have no... I think when people say that stuff, and this is not to be that mean, but they're thinking about what they can do or what they feel is likely that they could do. Maybe they don't even know what they could do. Maybe if they tried it, they could do it, right? But they're just being negative Nellies, honestly.
Yeah. What made you make the engine of the witness in-house? Why not use what you might consider quality engines or external libraries for your project?
Well, there weren't really any back then. There's only maybe starting to be some quality libraries now, but that, in 2000 and whatever, 2008, when I started the game, for one, there weren't that many options. There was like Unreal maybe CryEngine or something like that, Serious Engine, right? But especially for the more credible ones like Unreal, they were very expensive at the time, right?
That's true.
I believe the cost of entry to Unreal was like $100,000 plus 25% of everything you make, for example. It's not how it is now, but that's how it was back then, right? But that's not even the biggest reason. The biggest reason is because I think it's cool to make an engine, right? First of all. And then secondly, the reason I'm making the game is because I want to make a very good game. And making a game good just talking about the design for a second, spans many levels, from very coarse things like what in general is the game about and what do you do, what are the ideas of what you do, down to very fine-grained things like exactly how does it feel when you do a certain thing at a certain time, right?
Yeah.
And when you own the code base, or when you have the source for it and you built it and it's made to do exactly the thing that you're doing, then you have the maximum ability to go and tune the knobs to exactly what you want, right? Because there's not all this stuff getting in the way. There's not something that works in a confusing way that you don't understand and that you're only kind of repurposing to do what you needed to do. No, you built the thing to do what you wanted to do. And so the level of potential fidelity you have is basically unlimited, right? Now, it costs time to go in. If you're going to go in with a microscope and really fix everything, it costs time. And eventually you might run out of time. But if you give yourself the time, then you're really unlimited in what you can do in a way that is not true with another engine, even if you have source for that engine and whatever, right? And then lastly, I think it's important to be able to make available the things that I and the team are making indefinitely into the future, right? If you're making works of art, if you want people to be able to experience them in the future, then the worst thing you can do is give them an expiration date or a question about whether they'll be available in the future. So if you use some complicated engine, then you're depending on somebody's ability to port that engine to future platforms or your ability to port that engine. And believe me, it's a lot harder for you to port a generalized engine than your own specialized source code, because again, the generalized engine is doing all kinds of stuff that 10% of each thing is actually what you wanted to do, but not just getting that to run at all, but then making it work exactly the way it used to work, reproducing the feel of how it ran on some system 20 years ago is very hard. Like the bigger and bulkier and less apropos to your problem the code base is. Whereas if it's yours, you can do that directly, the same as you did during development, right? So, and you may not even be able to, depending on what the intellectual property issues surrounding the engine you're using are, you may not even be able to make it available in the future. So all those things are why I think it's the right decision. And then plus, if you're starting a game studio, it is true that building an engine is a substantial investment. It costs time, it costs money, right? It costs people having to work hard and get stressed about things. But you sort of only, these days, you sort of only really have to do that the first time. And then after that, it becomes easier because you've got a thing and you maybe modify it, you maybe replace some parts, but we don't really rewrite engines from scratch anymore. Whereas when I got into games in the 90s, you rewrote everything like every 8 months. It was ridiculous. That's not how it is anymore. And so once you've built an asset like that, you have the asset, as long as you don't, let it rot.
Okay, and I think you're accomplishing also you're reducing external points of failure, right? Because they're all under your control. So if something terrible happens in some part of your game or software, then you have the absolute control to make the changes.
Absolutely, yeah.
Yeah. So if you had external libraries that maybe you have to contact the vendor to fix your bug for you, that would be a huge time waster too, right? So these are trade-offs that you're making.
Yeah, and it also, so this is also one of my peeves about open source software.
Oh boy.
I'm going to bridge this into, this is not really open source bashing.
Okay.
Whoa, I think I just kicked my monitor cable. Hold on. I'm going to keep talking while I look under the computer and plug in my monitor cable.
Okay, no worries.
Yeah, it's a little loose. So, there's a thing that I'm going to call product mindset, right? And it's not necessarily about commercial products. It's about any time you're trying to make something good. So product mindset isn't even the right word, but that's all that's coming to me right now, right? And it's something that NASA actually understands even better than I do, right? It's about like, there's a thing that has to happen to a very high level of quality.
Absolutely.
And boundaries between modules or whatever are not excuses for why that thing doesn't happen as well as it needs to, right?
Correct.
So it's like that lander has to land and it has to like deploy its solar panels and whatever, like all those things. If those don't happen, then it's somebody's fault, right? Or at some level of the thing, somebody owns the responsibility that these things will happen.
Accountability is a major thing here. Yeah.
Yes. And that's exactly what doesn't happen for, like, open source is the opposite end of the spectrum, right? It's like, well, the network manager GUI, someone files a bug, I file a bug on like the network manager GUI on Ubuntu isn't working. Like my Wi-Fi isn't happening. What's going on? And they're like, oh, that's not really a network manager problem. It's something about the way it's interfacing with like some other command that it's running behind. And you're like, and so then it never gets fixed, right? In this way that it's just like, blame it on somebody else. Because there's this way of compartmentalizing into things and then calling it somebody else's problem, which is why open source has never been ready for the desktop, because there's nobody who, aside from ostensibly Ubuntu, who owns the experience and is going to make everything work where the buck stops there, and they're going to make the changes necessary, right? Now, of course, then they got interested in their own like other UI that sucks, and so that went down the drain as well. But so that's a thing that happens when you're making a game, right? I'm making the game because I care about what the experience is of the player playing the game. And that involves everything. It involves what the game looks like, what it sounds like, how rapidly it refreshes frames. Like, does it drop frames? Does it respond well to the controller? Are there a couple frames of lag between when you press go forward and when you see yourself go forward? Like, all that stuff matters. And in general, what we said about abstraction in the beginning is very relevant to this, right? Because abstraction is usually about, okay, I don't care that much about details and that kind of thing, like latency. Latency is a detail, right? Subtleties of motion are details. And so at some point, you will find, if you use enough different packages or whatever, that they are not making you happy with regard to those details. And then you have to step in and change that, right? You have to own that. Okay, this isn't working to make the best experience. And then you have to go do whatever it takes. And that's the thing that game people understand, is the whatever it takes part that other software people don't seem to understand. It's like, okay, this is a bug in the graphics driver. Like, you know, we shipped the witness, and on the ATI R980 cards, which we had an R990 and like an 890, but we didn't have a 980, right? And on the 980 only, we would crash very quickly, right? We were like, what the fuck is going on, right? So we had to debug that. And we shipped a version of the game that turns off a number of graphics features only if we detect a 980, right? And it's like, because it wasn't our fault, right? Most crashes were not our fault. Almost all of them were graphics drivers, but we were doing whatever we had to do to make the software that we were shipping at that time work the best as it could for the largest number of people. Now, if the PC ecosystem were nicer, we wouldn't have to do nearly as much, but that's the world that we live in, right? And so I just don't think a lot of people get that, even people that go to start game companies or something, right? But then going back to the topic of software, the less control you have over your software, the less agility you have with which you can respond to that kind of problem. It's like you said, if you have to go talk to some vendor about some problem you're having, and they're going to think that you're having the problem because you're an idiot, right? And whatever, and then it's going to go into some big exchange, and maybe eventually they address it in a passive-aggressive way that doesn't really solve the real problem, like whatever. The more of that you have to deal with, the less you can really solve the problems to the degree to which they need to be solved. So the more you write your own stuff, the more you don't have that problem. And this is true, again, to go to private industry for a second, right? SpaceX, for example, internalized its tool chain to the largest extent possible, so they wouldn't have that kind of problem.
That's right.
I don't know if that's true anymore, but that's what I was hearing about them a couple of years ago. Was like they were making rocket parts that normally you would buy from a vendor, and it was because they had so many problems dealing with vendors, both in terms of timeliness and just quality of parts, right?
That's correct.
Now, somebody like that, somebody making a spaceship or a car, has to deal with a way more complicated supply chain than somebody who makes like a video game. On one level, it's a way more complicated supply chain in terms of the number of vendors and the number of parts, right? But on the other hand, each individual part in software is actually insanely complicated, right? So you may only be dealing with like 15 libraries, but they're all any one of those libraries has a nightmare number of bugs that you're only accidentally not triggering, right?
Yeah.
It's through luck that you're not causing those libraries to fail. So we have our own intense complexity, I guess.
You know, when you say that, I also think about what people, again, vendors will do with undefined behavior from a standard when they try to develop a compiler.
Oh yeah, that's the whole thing.
What thoughts do you have on that?
Well, it's so obvious to me what the original intent was, and I'm on that side of like, I can't believe you guys are being such jerks about this, right? The intent was just, look, we're making C a language that is portable to the maximum extent possible, but you can do machine-specific things in it, right?
Yeah.
So it lets you do both, right? And in fact, there's this whole tradition in C, right? Like I'm if-deffing for a certain platform. So, if I'm little endian, I'm going to do this. If I'm big endian, I'm going to do this. Whatever, right? So all this stuff is being willfully ignored by people who want to just get video game high score for compiler optimizations, like on optimizations that aren't even very interesting, actually, and that do bizarre stuff to your program. And it's like, just cut it out, right? I mean, and it's ridiculous, like undefined behavior. So you're not even allowed to assume that your integers are 2's complement, right? Which is ridiculous, because no shipping platform that I know of is not 2's complement at this point. There might be some very, very, very old non-2's complement machines in a basement somewhere. But the fact that you're going to break my code because it assumes 2's complement is insane. It's completely bananas, right? And the way it breaks it is totally non-intuitive. It's just like, oh, your program's going to do something different now. That code's not going to run anymore. It's just going to silently not run. Great. it goes faster because it's not running. It's like, okay, that's a nice optimization, but yeah, whatever. I think it's compiler writers need to understand that their job is to help you program to the greatest extent possible, right? It's to help you get your code done as fast as you can, to help you find the bugs in it as quickly and as pleasantly as possible, and to generally make the programmer's quality of life as high as they can. That is the job of the compiler writer, and some people seem to have forgotten this.
Yeah, it'd be nice if they went to my work area where you have the longest list of requirements that you will ever see in your life, right? We are on the extreme end of, like, we can spend 2 weeks analyzing 3 lines of code that were added to a specific subsystem, right?
Sure.
And you can have dozens of people deliberating whether or not it's a good inclusion. Maybe if they have some of that experience, because they're literally writing, we are literally writing code that can kill somebody. Maybe they could do a better job with doing platform-specific implementations of undefined behavior if they need to.
Well, here's the thing is, so undefined behavior is a weird phrase, right?
Sure.
Because I think that was a mistake to call it that, right?
Okay.
It should be called system-dependent behavior, right? Or platform-dependent behavior or something. Yeah. If you had called it that, or were you as the person writing the spec, if they had called it that, then there wouldn't be a debate, right? Because it'd be obvious. Also, you know, there's a few things that were sort of mistakes, right? Like, oh, if you write shift by something by 32, if it's a 32-bit integer, right, that's undefined behavior. Whereas really it should be, well, it produces an undefined value, right? I guess they wanted to leave open the possibility that some hardware could throw an exception on that or something, and that's why it's undefined behavior. But again, I don't know. I think in retrospect, maybe that was an easy mistake to make, but especially when you consider how old C is.
Yeah.
But that should be revised, right? That should be called, you know, returns a system-dependent value, right?
Yeah, absolutely. You know, with 30 minutes left, I'm gonna have people start posting their questions.
Okay.
But while they're posting their questions, I do have one more thing to ask, which is,
sure,
what are, you know, back to your programming language, trying to address some of these issues. What has your programming language at this point? Because I don't remember quite sure when you started developing it, but how much have you accomplished at this point that you feel happy with?
Oh, I'm happy with the whole thing. I started doing those videos where I was talking about making a new language in late 2014. So it was like September, October 2014.
Okay. Yeah, I remember.
I started probably in mid to late October. And so I've worked on it by calendar year about 1.5 years, but is 4 or 5 months off that I didn't work on it because of the witness. And the other times it's mostly a spare time project. Although for the past week or so, I've actually been working on it full time as a break. And I'm really happy with everything. So the thing about those first couple of videos is, it's interesting because I was excited about those ideas at the time that I mentioned. But once I started actually building the thing and solving the problems in a concrete way, I came up with way better ideas that are in those first 2 videos. So all the way that compile time execution works, and the way you can do the equivalent of C++ templates, but use compile time execution to, like, you know, sanity check and manipulate the values. And the way you can introspect on the types in your program, and the way you can now introspect on your code and modify the code is all just super cool.
Yeah.
And like I was saying at the outset here, the way that you don't need some external tool chains, you can just write, this is how my program builds, and you have no operating system or platform dependency. It'll just run everywhere, and you can have an arbitrarily sophisticated build system. Like, that's all so good that it's like, there's no way that people can ignore it. Like, when people say a language is hard to make, assuming that I get at least some number of people to use this language, there's kind of no way some other languages can ignore some of these things, because they're so much better. It's so much better not to have an operating system dependent way of organizing your files and building your thing, that I like to think that people will just sort of be shamed into doing something similar or having to compete. Although, again, it's non-trivial, and you have to make your language work very differently than those languages do. So maybe you'd have to
Yeah.
make a new language or a whole new extension or something. But um, I don't know. I'm optimistic about all these things, we'll say.
Fantastic. Um, we got a shit ton of questions already. I'm gonna
All right.
I'm gonna have to cherry pick a few, but you know, you're basically writing a compiler. That's what you're doing as well for your language.
Yeah.
So somebody's asking if you recommend any literature, any books
No.
on writing compilers.
No. Stay away from all that stuff, because all the first couple of languages I made in school, I was learning according to that kind of literature. So it was like, now let's build a lexical analyzer. Let's use tools like Lex or Flex or whatever the modern equivalent of that is. This is garbage. Like, a lexical analyzer is the easiest piece of code to write. And just like, because it's so core to what you're doing, you want it to be exactly what you want it to be. You don't want it to be some weird, academically created system that you only sort of understand and that you have to work hard to make it interface with the rest of your code. Like, that's garbage. Same with parsing, right? You don't want to use Yak or Bison or whatever the modern equivalent is of those programs. You just want to write a parser. Now, there are advantages to using a lexical analyzer and a parser generator, and that is that you can detect ambiguities in your grammar which you may not be aware of. But I'm a big advocate of just don't even get specific about the grammar till later, right? Like I always say on my language podcast, on my language casts, the grammar is not even final. I don't care what it is, right? I'm building the semantics and the capabilities, and then once I have all those put together, then I'll figure out how you type it, right? And what I'm doing now is all provisional. Now I try to make it the best provisional thing and to approximate the final thing as most as I can. But if I have to change everything about the syntax, it's fine. Then my approach will be, when I'm finalizing the grammar, then I'll dig out some parser tools and not actually use them to generate the code I'm going to use, but use them as verifiers to verify that my grammar has the properties that I think it does, right? That's how that stuff should be used, so that there isn't an ambiguity that I'm unaware of or whatever, but I'm not going to use the code they make. Like, forget that. So, and then, when it comes to other aspects of a compiler, there's stuff you should be aware of, but it's all, if you're an experienced programmer, it's actually all mostly simple, right? So like, static single assignment is a thing. Like, I learned that in a compiler class in school in the 90s. It's a useful idea to know, but it's not a very complex idea, right? You probably, it's probably worth going to some literature when you get really interested in optimization, because there's a lot of optimization techniques that are actually pretty sophisticated and you might not think of yourself, or you might not do a good job without a reference or something. But all that stuff comes way later. Like, you can make a fully well-running programming language without any of that stuff, and I recommend staying away from it. Now, however, if you just don't know how to make a programming language at all and you sit down and start typing stuff, it's also probably going to be a disaster. So maybe you look at how other people have done it. Although, again, I don't recommend looking at something like GCC or Clang, because they're insane amounts of code and they're just bananas. So you maybe find some simple languages that some people have done and you just go look at how they did it and learn that way, right? I'm sure that some people have posted tutorials on the web about how to write your own lexical analyzer or parser without parser tools. Go look at that kind of thing, right? But don't go look at like books of how you're supposed to write a compiler, because they're mostly just in the same way that I don't want people to go read a book about object-oriented programming to learn how to program. It's just kind of damaging. And it takes you away from the real issues, right? Again, the real issues, if we get down to what is the most important, the real issues are, how much does this system that you're building help the programmer build code and be happy about what they're making and be efficient about what they're making, right? And a lot of these things, if you have a parser generator, the parser generator doesn't really know what the human context is of the grammar you're generating, which makes it a lot harder to make good error messages. Now, parser generators have gotten better at that, but still not as good as if you hand code a parser, because you know exactly what's happening and you can tell people in very human terms what's happening. Whereas you could try to do that in parser generator generated code, but you always, again, you're abstracted a little bit from the concrete situation. So you kind of have to talk around that all the time, and it ends up with worse error messages. Okay, this is way too long of an answer.
No, that's good. Yeah.
Fabian is saying the LCC book. So I've never read that, but I will second his recommendation because it must be good.
All right, cool. Somebody has the link, please post it. You may keep asking questions, chat. I don't promise that I'll be able to get to all of them unless John stays on the chat afterwards for a little bit or something. But anyway.
I could stay a bit. We can see how it goes.
All right.
I tend to have really long answers to things, so I have to make up for that by staying a little bit.
All right, cool. There you go. So if I don't answer, if I don't ask the question that you asked, please ask it later, community. Anyway, next comes from Kirenga. He's saying that this audience demographic, I think he's talking about the handmade community, is 16 to 30 years old, so young people, and that we're still learning what took you apparently decades to learn. He's asking, what's the best thing to focus on?
There's no answer to that because there's so much, right?
Exactly. Yeah.
How to program well is such a massive, massive subject. It doesn't ever stop, right?
Yeah.
And I'm not claiming that I went about it the best way, right? I'm sure if I went back and scheduled my life, I could be however good I am now, like ignoring whether I'm that good compared to anybody else, right? However good I am now, I could have been here, let's say, when I was 26, right? Which is 18 years ago. So I could have been much more efficient about learning all this stuff. But I think that's true for most people in life, right? So I think you just have to follow what you're interested in, like I was saying, because that is going to guide what you're most excited about learning, right? That's how it worked for me anyway. But then also maybe have an eye to quality. Like I think we all know a certain kind of programmer that like passes a certain age and doesn't learn anything new or whatever, or doesn't learn things that are that sophisticated. You know, like I said, there's people who, like me, who grew up on basic programming and stuff, and then maybe they go to school and learn C or something, but then somehow for some people there isn't some mental sentinel that makes sure that what they're doing is always improving, right? And if you don't do that, it's very easy to stagnate. But if you do that, then it almost doesn't matter what direction you go because you're going to get better in some way, right? So it's all about the derivative of how good you are, right? Wherever you start, as long as the derivative is positive and sloped up high enough, then you're going to do great.
All right, awesome. I'm ignoring some of the witness questions or game design questions.
Off topic.
It's off topic. We're just talking about programming things. Anyway, this one comes, I guess we can ask this one, which is what your opinion is on virtual reality. And I might be able to tie that into what we're talking about, things that need to be performant and how that influences the way we program. So
okay. So I'm really interested in virtual reality as a designer in a certain way, which is that I've always, going back many years, I've always seen as a problem the very limited amount of bandwidth between the player and the game, right? You know, bandwidth coming from the game to the player is huge. We have these images, like with all these colors changing many times per second and all this audio and stuff. But going the other way, we have like a few buttons and a couple analog sticks, right? That's the equivalent of like 6 pixels on the screen.
Yeah.
It's really not very much. So what do you do about that? Well, with VR, the tracking is so good that you just have a level of intimacy and nuance that you never had before, right? So for example, say I wanted to make a crime scene detective game, right?
Yeah.
If I were to do it today without VR stuff, then you'd have some weird, first person mouse and keyboard controls, and you'd have like a hit control to duck, and the duck level would be like one level exactly, right? And you'd walk around, you might duck and look at something, and there's a limit on how subtle things can be there. Whereas if I'm actually in VR or something, I can like go and kind of look under this desk and do I notice the relatively subtle thing? Am I looking in exactly the right position at the right angle? You could do some like witnessy stuff there, right? And it would be very interesting, right? So I like the room scale VR stuff for that reason. Stuff where you just sit there, less interesting, but still having really good hand controllers, even if you can't move around, is pretty interesting. The thing that's least interesting to me actually right now is the experiential part of feeling like you're there. And maybe I'm wrong to not be as excited about that, but I think it's cool, right? But
Yeah.
in terms of what you can design, it's the inputs that I think are cool.
All right, nice. Next question that we'll tackle is somebody asking if you have a plan or people that are going to help out with the back end of your language yet, because he's assuming that you'd rather not use LLVM.
We may use LLVM provisionally,
okay.
Right? Like I imagine for whatever the first this is just random spitballing, right?
Sure.
But like whatever the first release is that we distribute to people and say, hey, you can kind of use this. You might run into a bunch of weird corner cases and send us bugs and stuff, and we'll get on them as quickly as possible. Whatever that time, right? I could imagine that we use LLVM as a backend for release builds or for platforms that we don't natively support. And then maybe we generate x64 binaries directly, because that's maybe not that hard for debug builds on our own platform. Now that you sort of have to figure out the debugging story for all that, but that's one way that it could go, right? Another way that it could go is you just use LLVM for everything, like whatever, right?
Yeah.
But the eventual story would be to replace LLVM, because like everything I just said about game engines and all that, you want control over everything so that you can adjust the quality of the entire system with a great degree of control and nuance, right? Just like an experience of a game. So, and just like Visual Studio, right? The longer LLVM exists and the more generally useful of a tool it is, the bigger it's going to get, and the more not for me it's going to get. The more it's going to have all this stuff, right? Like, why does, if I want to generate dwarf debugging, why does that suck? Well, in part because it's got all this weird virtual machine stuff for in case you wanted to do dwarf debugging for a Lisp program. Why do I care about that? I don't, but it's making it hard. Oh God, there's a car alarm outside. Anyway, but it's making it harder to do that, right? So now imagine LLVM just gets more and more like that over time. Maybe they'll somehow avoid that, but that's the course of like all generalized software systems that have a large audience. So the plan would be to use it for expediency, and then gradually, take over. And I believe that you could take over module by module, sort of, right? Like LLVM is doing all these passes, and you just sort of take the first pass and say, okay, we're going to do our version of that now, right?
Yeah.
And migrate that into native code, and then turn off that pass in the LLVM backend, and eventually you're free of it.
All right, cool.
But who knows? Who knows? Yeah. We have yet to see.
All right. Next question: how has the variable? Oh my God! Never mind. I thought he was serious.
I didn't hear you. Did you ask something?
No. The next question is, do you? Wait, this is weird. Okay, I get it. Will you switch to Vulkan for your next game?
I don't know anything about Vulkan. At first, I was very excited about the idea of having some API that I had more visibility into because it was simpler, right? So like, there's some line of where you call into, and then everything behind that is kind of a black box, except when the API tells you what's happening, which for OpenGL is very difficult. Even with all these tools that like show you the textures and stuff, like GL drivers are terrible about helping you understand what's happening. It's very easy to do something wrong and not know what happened. Direct3D historically was a lot better. I don't know how it is now, but around the DX8, DX9 days, Direct3D was very good about giving you error messages, as long as you were running the debug Direct3D. And it was very fast to debug, right? So I was excited that something like Vulkan or DX12 or whatever might give me that. What I've been hearing is that it's way more complicated than you would like, and that you don't get that much benefit anyway from using it. I don't know myself because I haven't looked at it, honestly. I'm more skeptical from what I've heard third hand from other people. So we'll have to see.
Okay. There have been some comments on what your thoughts might be on functional languages, right? And they're citing people like John Carmack who are apparently
Yeah.
really obsessed with that paradigm.
So I was taught functional languages in college, right? As first programming. I mean, I already knew BASIC and assembly and stuff, right? But so I was indoctrinated into that very early, and I kind of had to unlearn a lot of it later because a lot of it is just drinking the Kool-Aid. However, a lot of it isn't, right? There are reasons why you want to be functional wherever possible. Because, hey, if you have no side effects, first of all, you can't have bugs related to state, right? Secondly, you parallelize very easily, right? Because you don't have shared state or whatever, right? All that stuff that functional language people use as justifications of why functional languages are a good idea is true. All that stuff is true. However, there's also drawbacks that are not taken seriously enough by functional language people. And this is true with everything, right? Every technique that is developed that has a beneficial aspect also has a non-beneficial aspect. And you have to weigh those for your particular domain and see how they come out. And very few people, often the non-beneficial, like all the drawback parts, are often really subtle. Like, for example, hey, C++ templates sound cool. Maybe I realize that the error messages are terrible, but oh, don't worry about that. Compiler authors will fix that in a couple months. They're a new feature. I'm going to start using them everywhere. You may not realize how much longer your program is going to take to compile and how that's going to kill your productivity, right? Because it creeps up on you slowly, right? So things like that. Functional languages, I believe, take a toll on speed of code, on understandability of code, which is actually the most important thing, right? And on solving problems that involve state inherently. They make all that stuff harder and more complicated. And as Mike Acton would say, the problem is the problem, right? If the problem involves you managing state, no amount of wishing that wasn't true is going to let you do it without managing state. You're just going to hide the state
Monads,
under
bro.
more things
Monads.
And make it more complicated, right?
Yeah.
What'd you say there?
Monads.
Monads, yeah, whatever, right?
Yeah, bro.
It's just like you're just making it way more complicated to do the thing that needs to be done, and that makes it more buggy, harder to understand, slower, all those things, right? So a language which is, so just like you could have a language that is, has some features that can let you do a class encapsulation kind of thing in the cases where that is the most appropriate technique to apply, right? Can also let you write functional code in cases where that is the most appropriate technique to apply, right? And even C++ kind of has this, right? You declare a function. I mean, you can put const in so many places in C++, right? But if you put it, one of the places you can put const means that your function has no side effects, right? I don't know if it means it doesn't read globals, right?
I don't think so.
Which means it's not really functional, but whatever.
Yeah, it's
you can obviously do this, right? And so you can use functional techniques in an imperative language, right? Now, some functional techniques, the heavier weight ones, really require a garbage collector, but I also think those are the least useful. So like continuations are like a functional way of encapsulating something that, if you get really serious about it, is more about threads and program state or something. Like that's better understood in terms of what the machine is actually doing than in terms of some weird, like a continuation, for people who don't know, is a function that represents the future result of running your program, right? Which is hard to wrap your head around.
Yeah.
So you realize it's just a wrapper for stuff you already understand anyway, right?
Yeah.
It's the way of incorporating that into a functional paradigm. But all that stuff is not really the right way to do all that stuff anyway. So you might as well acknowledge that you're running on a computer and do things that way. So, I think it is true, though, that more functional language techniques should be adopted. I am just not a big fan of programming in the actual functional languages that are available. So I will, for example, in the language I'm working on, I'm going to have there to be a way for you to say very clearly and without any confusion, this is a pure function and it can only call other pure functions, right? And then maybe there's a gradated way where you can, I think, like I said in one of their very early demos, like you could delineate actually what state you're allowed to see from those. Because sometimes you want some pure functions, but you also want to read a debug variable that helps you figure something out, right? Or write a debug or something, right? So, and then when you go to release, it's purely functional or whatever, right? You want to be able to manage these things very easily. So if you look at the actual problem, which is I don't want side effect, I don't want bugs due to side effects, or I don't want to have to think about if this piece of code is going to mess with this piece of code. I just want them to be independent with no thought, right? That's a great problem to try and solve, but I don't think you have to buy into a giant Bible worth of dogma in order to get good solutions to most of that most of the time.
Gotcha. Yeah. Here's a fun question. Do you think you're going to keep programming and making games into old age?
I hope so, although, man, sometimes, I don't know, like, I'm tired sometimes. It's a lot. Like, I work hard, but I like what I'm making. I mean, The Witness was the best game that I knew how to make, and this language is the best programming language that I know how to make. So as long as I can keep doing that, I'll be happy doing it. So yeah, we'll see. I don't know.
Would you switch to development over to Linux if the debugger tools were actually good?
Yes.
Interesting.
In fact, Microsoft is driving Windows into the ground, right?
Is that the universal Windows platform issue? I know there's something.
Well, that's the latest thing.
Okay.
Many, like, Windows 8 is just when it started going overboard, right? Like, Windows is not anymore about making a good operating system. It's about, squeezing people for the most money. Which you could sort of argue is what Microsoft is all about, so why were you kidding yourself? But there was an initiative, like the whole Windows NT initiative was about, like, okay, let's build a real good operating system, right? And when they switched to the NT, and then like Windows 2000 and all the later operating systems, it was a very big step up in the quality of what you were using. But at this point, it's just garbage at every level, everything new that they do. So it's going to sink eventually. I don't think they're going to save it. Or maybe it's just the least bad option and it just gets worse and worse, but everything else keeps getting worse and worse. Because like I say sometimes, like, I've been using Linux since Slackware in like 1992 or whatever, right?
Yeah.
I would boot up my PC at home and, like, Bob's face in ASCII would be like right there.
Slackware.
Yeah, that was pretty cool. And I used Unix systems before that, since 1989, right? So I've been seeing what this is like. And Linux today is worse than it was 5 or 10 years ago. It just doesn't run as well. Like, user programs are more broken. It's more bloated. It's harder to update, like all these things. It's falling apart. And so Linux people need to get their act together. And I think it would be pretty easy if everybody decided, rather than making their own damn distro, to, like, pitch in and make something better, take responsibility for the experience and have the buck stop there, like I talk about, that things could get radically better. But getting back to the thing you exactly asked about, which is debuggability, debugging on Linux is terrible. And I think part of the reason it's terrible is that most programmers there just don't understand what it could be like. Like, Visual Studio is not even that good, but it's so much better than anything on Linux, right? And I tweet about this, and people reply to me seriously asking, like, what's wrong with GDB? That's a perfectly good debugger. And it's like, okay, if that's all you've ever used, then that's fine. But you know what? I used GDB in like 1989 to 1994 at college, and it was exactly the same as it is today. All right? Right. 22 years later, you're debugging with the same level of technology. Like, what? How is that okay? It's not. Okay? So... And like I say, it's getting more visibility into what your program is doing is actually pretty easy if anybody gave a shit, right? So like that, I gave a demo the other day where I had, my version of Sean's version of my really old profiler running in the new language. And, Sean did most of the work actually, because my old version wasn't that sophisticated, but whatever, I had it running, and it just gave you a lot of visibility into what your program is doing, right? Mm-hmm. That didn't take that long to make. I mean, I was basing it on Sean's work, but I don't think Sean spent that long on it. He might have spent a couple of weeks or something. I don't know. But like in terms of the investment of how many programmers, if they had that, would be what % more efficient? It would be insane, right? And then because they were more efficient, developer tools would be get better faster, making you more efficient, right? There's a compound interest curve that happens that is not happening really on Linux. They don't seem to understand that. And that's very frustrating, because now more than ever, the world kind of needs to switch to Linux or we're screwed. Or somebody needs to make a competing operating system, but whatever, right? So I wish that they would get it. And, I say they, where I could easily be one of they if I could if I could sacrifice the amount of productivity that I have due to working on Windows rather than Linux. I don't know how much productivity I would lose, but it's probably at least 20%. I don't know, 20%, 30%. Wow. If you take into account how bad graphics drivers are and the fact that I do 3D all the time, it's probably more, right? That would kill, if you look at the amount of software I can make over my life, it would kill it, right? So I don't want to go there yet. Now, if my language is good enough and I manage to make my own homebrew debugger for it, because if you're making your own debugger, you don't have to speak these very overcomplicated generalized formats, right? You just write your own format out that's very simple. It's trivial, actually, to do that. And then you write a program that visualizes it. So the kinds of things that I've been using to visualize stuff in demos lately could just be a really workable first-level debugger, right? Depends. I haven't tried that. So maybe there's a complication there that I haven't thought about. But, if I get that going well enough, then maybe I can switch to Linux. If I can ever get a damn Linux distro to install on my laptop and use the audio correctly and use the keyboard correctly and use the mouse correctly enough to let me turn off tap to click on the mouse so that I'm not accidentally clicking on everything all the time. If they could even get that right, then I would switch. But last I checked, that was not even possible. So
some of them might be because of the open source software mentality where there's the code, you can patch it if you need to.
Yeah, but I'm trying to do other stuff. So this is exactly what I was saying about taking responsibility for the thing, right? So I have a Razer Blade laptop now. I had a slightly older one last time I tried switching to Linux. It was like when I did those first demos for the new language, I wanted to show in Linux and on Windows, right? So I switched to Linux. I got everything working there. It was fine. But I had to use an external mouse because the trackpad, whatever it reported its name was on USB or whatever, and Linux must use string matching or something. It looked like a generic mouse USB device, whatever it is. Maybe the code that it transmits, maybe it's a numeric code. I don't know anything about how you recognize these devices on USB, but whatever that is caused Linux to recognize it as a mouse and not a touchpad, and therefore not give me the touchpad interface. And I could not, searching on the web for hours, find any way to get around that, right? So I was unable to do things like say, hey, this is a touchpad, turn off tap to click and whatever. And so I would have to turn off the trackpad every time I would start. And you can do that with I forget, there's some X command where you disable a device. And of course, the numeric ID changes every boot. So you have to run a series of 2 or 3 commands to see what it is, right? And then I finally disable that, and I'm using the Windows system, which was Linux Mint Cinnamon edition, right? And frickin' Cinnamon would hang, just frickin' soft lock on me so that no further input would work every once in a while. So then I'd have to Control Alt F1 or whatever to go to a text console and kill all Cinnamon restart or whatever. And it's just a disaster, right? And I can't believe that people are letting that ship. It's like I'm saying, nobody is taking responsibility for that experience at all, right? What you do, if you're shipping Linux to people, if you're part of the open source community and you're a person who works on Linux, what you're supposed to do is say, these people with Razor Blade laptops have problems. It's maybe not our fault. Maybe they're supposed to identify their trackpad in a certain way and they don't, right? Maybe, well, I don't know what the deal was with Cinnamon. It's probably just Cinnamon's problem, in which case you don't ship Cinnamon to people, right? Until it fucking works. Yeah. But with the trackpad thing, it's like, it's your job as the person managing the distro to fix that, right? If you're not going to go make that experience work for people, even though it's not your fault, you have no business running a distro. That is because that's what it means to ship software. And that's the idea that open source people don't understand. And until they do, Linux is never going to be ready. But I want it to be ready. I desperately want it to be ready because I want to get off Windows as fast as possible because Windows is becoming a nightmare.
And with that, let's answer the last question that I'm going to voice.
That was a really long answer, man. Sorry.
No worries. Chat, I know I skipped a shit ton of questions, but Jonathan agreed to stay just a few minutes after the stream.
I will stay, yes.
Awesome. But I'm going to pick this one because it has to do with the future of your language. And I love ending streams with very speculative questions. This one is from, I think I lost it. Where are you? Well, I remember it. It's from Popcorn was asking, many popular languages are owned by big corporations. They spend a lot of money into these platforms. Do you think, what the future of JAI would be? Like, at which hands is it going to fall into? And I guess he's asking, like, are you going to open source it or not? Things like that.
Yeah, I'm going to open source it. And I've been advised that I should do something tactical around that to prevent a Microsoft-style embrace, extend, extinguish attack, which they might not be competent enough to do anymore. I don't know. But somebody else might do that, right? So, but yeah, I mean, the language should be made free for whoever wants to use it. I think that's the only reasonable thing to do. It's true that a lot of languages are highly commercial in their impetus, like, C# or whatever. But a lot of them aren't, right? Haskell isn't commercial. That's kind of popular. Just on the functional language end. And then on the imperative language end, like PHP and JavaScript are free, right? So, they're not very good, but they're not commercial. C is not commercial, right? So I think it's not too hard to avoid that. I think people might be looking at a couple of, even stuff like Rust, that's not commercial. D is not commercial. I think most languages that you could name are not commercial. So it's really the exception when you get something like Swift or whatever.
Yeah.
I don't know what the situation is around Swift. I guess they're open sourcing it or something, but I sort of feel like it's still uncontestably controlled by Apple. So whatever, Yeah,
no, that's a mess. John, I wish we could talk for more. Hopefully I can have you sometime later this year.
Sure.
Have you again. But it's been really a fantastic conversation. One last thing. If you were to give advice to the Handmade hero community, Handmade dev community, again, most of us are really young programmers that are interested in these kind of approach to performance-oriented programs. Any advice, any suggestions for us? We really do look up to you, and we want to make you proud, if that makes sense.
I don't know, man. I don't know anything to say that's not generic, right? All the programmers I know who are good have a few things in common, right? They're all smart, but being smart is kind of a side effect, I think, a little bit. Like, I think if most people do the right kinds of things, they get smart. So, and one of those things is working hard on things that are hard to do. And one of those things is being interested and having ideas about what you want to do and what you find interesting, right? So I think as long as you do that, then you end up being a really good programmer, right? And as long as you don't relegate programming into some box that's like, oh, that's just what I do for work, right? Or I don't identify as a programmer. I just go to a job and do that, right? Those people tend to not be the good programmers, although even once in a while you get surprised by that. So really, again, I think it's about finding your particular interest. What do you really want to do? Maybe someone on this stream really wants to save free operating systems and is going to go out and write a good operating system. You know, like I think this might be the right time to do that, because I think, for example, you know, a good operating system started today might be very security minded and start with all the applications siloed and then figure out how to do good communication. Let that be a good productivity OS while keeping everything siloed, right? For example.
Yeah.
And if you did that, it might be very easy to take over from Linux, because you're giving people a different thing that they might need. So there's always opportunity, right? If that's what you're interested in, do that, right? If you're interested in games, do games. Just know that it's hard sometimes, right? Like I said, being a good programmer is really difficult. There's a lot of things to think about and a lot of issues to deal with. And it gets complicated, and often you feel like you're dumb. So you just stick with it and make sure you always get better, and you do get better, and then eventually you're really good. So yeah. That's it.
All right. Ooh, fantastic advice. And again, thank you. The website, Handmade Dev, is, we're really doing interesting things, right? We're already hosting Casey's forums on Handmade Hero. Handmade Dev is also hosting the 4Coder project, which I'm sure you're following.
Yep.
And Handmade Quake, and we have other programs that I think are of the same quality. So, we really are interested in kind of these, in making a small dent, even if it's a small dent in the software development community. Just know that, there is a group of programmers that feel the same way, that share the same gripes that you share.
That's great. And I think actually giving it a name and a place for people to go is very, very valuable, right?
It legitimizes the space, right, of these people that want to make that.
Yeah, totally.
So once the website's released and we have a growing community, I'm going to make sure that you come back to the show.
Okay.
So you can comment on all the different programs and things like that. So I think that'll be great. Cool. All right. So I'm going to have you leave the Hangouts call if you want to, and then answer questions from the chat. But,
all right, cool. I'm going to take a break for a few minutes too after that. But
okay, I'll just say some parting words.
Gotta refill the tea.
Okay. Thank you so much.
Sure.
Yeah. Talk to you later then.
Bye, everybody. Except I'll type to you in a second.
Yeah. I don't think I have ever felt so satisfied with what the Handmade Dev community is really striving to do. So huge shout out to Kelimian or Jeroen. He's the lead developer for the website. Huge shout out to Andrew Chronister, the front end developer. Huge shout out to my moderators, Insofaris and D7 Samurai, and just the entire Handmade Hero community, Casey Muratori, Sean Barrett, Fabian, all the people that I've had on the guests, the Handmade Dev community, all of you guys, right? We are going to make the software development community better. And, no matter how big of a dent we make or not, it's going to make a change. And I think it's going to be in the right direction. So thank you so much. Season 2 is going to be 2 weeks from now. So I'm taking a 2-week break. And I'll be back, and I'll be having people from NASA or SpaceX, and I'll continue having people from the game industry sharing their thoughts on this kind of approach to programming that we're trying to make, quality software. If you're interested in season 2, go ahead and follow me on Twitch. I don't have the thing, but it's obviously twitch.tv/ArnoldKoitenberg. Go ahead and do a follow there, or just follow me on Twitter, and check out handmadedev.org. All right, check it out. It'll be released soon enough. So thank you guys. This was amazing. Talk to you later. See you on the flip side. Handmade Jeff Show.